This first lesson has to do with what's called inductive reasoning. Inductive reasoning is actually something that you do all the time. It's also known as critical thinking. Sometimes it's also known as common sense. So just imagine folding a piece of paper in half and then unfolding it. If you unfold the paper, it's divided into two rectangles. If you refold the paper and then fold it in half again, there are four rectangles. So we've got one fold, two rectangles will be formed. Two fold, four rectangles will be formed. And if we keep going, we could figure out how many rectangles we would get if we folded a piece of paper in half 8 times. Well, if you can figure out the answer to how many rectangles we'll get after folding 8 times, then you've done what's called inductive reasoning. So one fold is 2 rectangles, two folds 4 rectangles, so every fold we have twice as many rectangles. So after 8 times, we should have 16 total rectangles formed. If you didn't need to fold the paper and you could just figure that out in your head, that's called inductive reasoning. So inductive reasoning is looking at a pattern or looking for a pattern in order to arrive at a conclusion. So we're going to use inductive reasoning to find the next two terms in each sequence. So for example, A, if you notice 3 times 3 becomes 9. 9 times 3 is 27. 27 times 3 is 81. So what's happening here, I've used inductive reasoning and I've figured out that multiplying each previous number by 3 is going to give me the next number. So the next two sequence terms would be 81 times 3, which is 243, and 243 times 3 is 729. So what I'd like for you to do now is to pause the video and to look at the examples given and see if you can come up with the next two terms in each sequence. So pause the video and then unpause it when you're finished to see if you got the same answer that I did. You should have had something like this. Obviously, you freehanded it just as I kind of did, so it's not going to look perfect, but you should have 5 lines in here and then 6 lines in this circle. If you didn't get that, raise your hand or ask a neighbor if you're confused. So after you've used inductive reasoning to figure out a conclusion, that pattern that you noticed is called a conjecture. That conjecture is what makes it possible to find any term in a sequence, because now that you know how you get to the next term with your conjecture, you can find the next term. So looking at the circles, what conjecture can you make about the number of regions that 20 diameters will form? A diameter is just a line that goes through the center of a circle. So we've got 1 diameter, 2 diameters, 3 diameters, and so forth. So how many regions, pause the video and take a minute to think about it. How many regions do you think that 20 diameters are going to form? Write that down and that would be your conjecture. And you're going to want to pause the video, respond to the question, and then unpause it to see if you got the same response that I did. So the answer would be that the 20 diameters would form 40 regions, and your conjecture is that there are twice as many regions formed as there are diameters in the circle. Raise your hand or ask your neighbor if this confuses you or you didn't get the same answer that I did. Not all of your conjectures are going to turn out to be true. You should test your conjecture multiple times. You can prove that your conjecture is false by finding one counterexample. And all a counterexample does is proves that your conjecture is false. Okay, so a counterexample for each conjecture, we'll do the first one together. If a month starts with the letter J, it is a summer month. Well, I want to prove that this is false by thinking of a counterexample to that statement. A month that starts with the letter J is a summer month. Well, January is not a summer month, and it does start with a J. So all you would have to write for your counterexample would be the word January. That word, January, proves that this conjecture is false. So I would like for you to pause the video and see if you can try example B on your own, and then unpause the video to see if you get the same answer that I did. For the next example B, you could have drawn a picture of something that was 4 points but not a rectangle, or you could have drawn just written the word rhombus, trapezoid. Those are examples of 4 points connected. 1, 2, 3, 4 that do not form a rectangle. Okay, Venn diagrams are something that are often used in science, used in English class a lot. It's just a way to organize your idea. They're usually represented by two interlocking circles. But to get into Venn diagrams, we've got a little bit of vocabulary. The first word is a conjunction. And a conjunction is just basically forming a statement with the word and. Basically, conjunction means and it is the space represented by where the two interlocking circles meet. We use the symbol that kind of looks like a triangle without the bottom part. So if I did P arrow up Q, it's read P and Q. Statements can also be joined by the word or, and these are called disjunctions. And so if I write P and then this symbol, Q, that would read P or Q. The way I remember the difference between and or is that the and kind of looks like you're about to write the word A for and then or, you can make it look like an O. So conjunctions are used, are illustrated in Venn diagrams. This area right here would be your conjunction, where the two ideas meet. It's an and statement. So we have Richmond is a city in Virginia, and this is the R, stands for Richmond, is a city in Virginia. So what can we determine about Richmond from the following Venn diagram? So an example of writing that as a conjunction is that Richmond is a city in Virginia, and it's a U.S. state capital. And for the next example, I'm going to illustrate what disjunction is. It's used in a Venn diagram. And a disjunction is when we talk about two separate ideas. So we have U.S. state capitals, or we're talking about cities in Virginia. So an example might be, there are places in the United States that are United States capitals, or they're cities in Virginia. If we wanted to write this symbolically, I could call U.S. state capitals my P and cities in Virginia Q. So anytime I talk about P, it's U.S. state capitals. Anytime I talk about Q, it's cities in Virginia. And I could write this as P or Q. Another way we can talk about Venn diagrams are as all, some, or none statements. If you have two interlocking circles, it's read as a sum statement. If you have two circles that don't touch at all, it's written as a no or a none statement. So for example, the letter A, we have some students are musicians. Those students that are both students and musicians lie in this area right here, the conjunction. So to write a sum statement, we would say that some students are musicians. So example B, the circles are not interlocked at all, so I'd like for you to write a no or a none statement about triangles and squares. Pause the video to see if you get something similar to what I did. So very simply, we could say that no triangles are squares, or you could have said no squares are triangles. The order doesn't matter. And then we have Venn diagrams where you have one circle that is completely surrounded, this circle, completely surrounded by another circle. Those can be represented as an all or a sum statement. So if I were to read this Venn diagram, if I go from the inside out, I would say all. So from the inside out, all pitchers are baseball players. So if you are a pitcher, then you are a baseball player. If I read it from the outside in, so if I start here and go in, it's a sum statement. So I could say some baseball players are pitchers. And that's true, because if you're a baseball player, it doesn't necessarily mean you have to be a pitcher, it just means that you could be. So from the inside, or from the outside in, it's a sum. And from the inside out, it's an all statement. And the last type of example that you'll see is when you have three interlocking circles. You have to break them apart one by one and try to look at each one separately. So if I were to highlight this circle right here, that means everybody that's in this circle is in the fundraiser club. If I look at this circle here, everybody inside that circle belongs to the teacher recognition club. And then if I look at the third circle, everyone that's inside this circle belongs to the awards program club. So for the first example, it says which region, and the regions are labeled A, B, C, G, H, F, E. Which region represents students who do not belong to the fundraiser, teacher recognition, or awards program committee? That means that they will not be in any of those circles because they don't belong to the fundraiser club, they don't belong to the teacher recognition club, and they don't belong to the awards program club. So which region is left over? And that would be this region here, the 4 students that don't exist in any of these circles. That's region A. The next question is completely opposite. It says which region, A through H, represents students who belong to all 3 committees. So what I would do is highlight all 3 circles and see where all of the highlighting overlaps. So we want everybody that's in the fundraiser club. I'm going to highlight the fundraiser club. I'm going to highlight the teacher recognition club. And I'm going to highlight the awards program club. And I'm going to see where do all 3 of those colors come together. So if you look right here, we have green, yellow, or sorry, this is blue up here, yellow, and green. So this region is where all 3 colors came together, and that would be region E. Now if you had a hard time seeing that, look up above. Do you see that there's only yellow encompassing the circle and there's only green encompassing the circle? And when I mean encompassing, I mean it kind of looks like a parentheses would look like this. And we come down here, we've got the yellow, and we've got the blue, but we don't have the green. So it's not this region either. We're trying to figure out where all 3 of them came together. Okay, so I would like for you to try example 3 on your own. We want to know which region, A through H, represents students who belong to the awards program, so belong to the awards program, and the teacher recognition program, but don't include those that are in the fundraisers committee. So highlight the teacher recognition, highlight the awards program, and then try to figure out where those 2 come together, and then eliminate the fundraiser committee. So pause the video, see if you get what I get, and then unpause it when you have gotten your response. Okay, and you should have gotten F. Region F represents where the teacher recognition program and the awards program comes together, but not the fundraiser committee. If you have a hard time seeing that and you'd like for me to show you or for a classmate to show you, raise your hand or ask your friend. And for the last example, number 4, it says how many students total belong to the fundraiser committee. So we don't care if they also belong to the teacher recognition committee or the awards program committee. We want to know how many are encompassed in the fundraisers committee circle. So what I'm going to do is I'm going to highlight the whole circle of fundraisers, which is right here. And anybody that's in this circle is in the fundraiser committee. It's okay if they're also in the teacher recognition committee. It's also fine if they're in the teacher recognition committee and the awards program committee, and they are also fine if they're here in the awards program committee. We just want to know how many of them are in the fundraiser committee. So that would be 9, 3, 2, and 5. So if we add 9 to 3 to 2 to 5, we should get a total of 19 students who belong to the fundraisers committee. Okay, now you should be ready to move on to your exit quiz. Your exit quiz is on Kia, and it should be labeled Inductive Reasoning and Venn Diagrams exit quiz, just as your notes are labeled Inductive Reasoning and Venn Diagrams. So if you look at the top of your notes, here's the top of your notes. Whatever the name of your notes that day is what the name of your exit quiz that day will be called.